What's up, wonderful students? Mr. Larson here. Today we're going to talk to you about properties of exponents. I don't know why I said we. I'm going to talk to you about properties of exponents. This video has 4 different properties. First one we'll talk about is negative exponents. So in general, we don't like to see negative exponents because with one quick fix, we can turn it to a positive exponent. So for example, if I had 4 to the negative third power, we don't like to see the negative third, so we think of that as a fraction. It's really 4 over 1 to the negative third. If I take the reciprocal of the base, right, 4 over 1 is the base, I can change that exponent to positive. So by taking the reciprocal of the base, the exponent can switch to positive. Okay, really it switches signs. So if it was positive to begin with, then it would become negative. But when it's negative to begin with, it can become positive. So this 3 really applies to the numerator and denominator. So it's 1 to the third over 4 to the third, which would be 1 over 64. So that's the other thing, is if you can simplify, you should definitely simplify. So let's take a look at one other version of something like this. If I had 1 over 2 to the negative second power. All right, I can take this 2 that has a negative exponent, I can swing it up to the numerator, right, do the reciprocal, and it would be 2 to the second over 1. Or in other words, 2 to the second, which is 4. Okay, next one, the zero exponent. So as long as your base is not 0, it could be any other number, positive or negative. If it's raised to the 0 power, then it is going to equal 1. So, 2 to the 0 power, that's equal to 1. You might have something like, there might be an expression. So it could be like 3 plus x squared to the 0 power. Well, that's equal to 1. You could also have, 3x to the 0 y squared. And we need to recognize that this part right here, x to the 0, that's just equal to 1. So it's really 3 times 1 times y to the second. Or in other words, that would be 3y to the second, which would be 9y squared. Okay, so sometimes it's the entire expression that's raised to the 0. Sometimes it's just a piece of it. Next one, multiplying terms with the same base. Okay, so for this one, a to the m times a to the n, we add those exponents. All right, so I like using 2. 2 is a nice easy number. 2 to the third times 2 to the second. Common misconception or common mistake would be to multiply that 3 and the 2, but really we're going to add them, right? Because this is 2 times 2 times 2. There's your 2 to the third. Times 2 times 2. There's your 2 to the second. So altogether we have 3 plus 2, which is 5 2's being multiplied together. Oops, I wrote the wrong number. 3 plus 2. So that's 2 to the 5th. Again, if you can multiply that out, I would expect you to. So 2, 4, 8, 16, that would equal 32. All right, very similar. If you have the quotient, if you're dividing a to the m over a to the n, you're going to subtract those exponents. So we have 3 to the 4th over 3 to the 2nd. That's going to equal 3 to the 4 minus 2, which would equal 3 squared, of course, which is 9. All right, let's suppose we had x to the 4th over x to the negative third. Well, that's going to be x to the 4 minus negative 3, which is really x to the 7th. Right? There is another way you could solve that problem. You could say, well, this x to the negative third let's bring it up top here so that it becomes x to the positive third. Then you could add those exponents and you're still going to get that same thing as x to the 7th. So a lot of times there's more than one way that you can go through these problems. I'm going to do 3 of these circle problems, and then you guys can work on the rest for practice. So number 4, 5 times x to the 0 times y to the negative 1. I kind of gave you a hint on the properties you're talking about here. 5 times x to the 0, this is really equal to 1, so it's 5 times 1 times y to the negative 1. That negative exponent we want to move, right? This is over 1. We want to move that to the denominator. So this should be 5 over y to the first, or just 5 over y. Number 7 down here, so the product of powers property. So anytime you have coefficients, multiply those together. So 2 times negative 4 is negative 8. And then I have d that shows up a bunch of times. I have d to the 7th, d to the 9th, d to the 5th. So this should be d to the 7 plus 9 plus 5, which would be negative 8d, I think that's to the 21st power. So those exponents don't apply to the 2 or the negative 4. Also, they wouldn't apply to the negative 8 after you multiply them together. Quotients, this is our division. Same thing, if you have coefficients, go ahead and divide those. So 2 over negative 4, that's negative 1 over 2, negative 1/2. I think what I want to do is multiply these together first. So let's see, negative 1 over 2. This is d to the 9 plus 5. That's really d to the 14th down there. So let's see, negative 1 over 2 times d to the 7 minus 14, right? The exponent on the top minus the exponent on the bottom, which will get me negative 1/2 d to the negative 7th. So I need to move that down to the denominator. So negative 1 over 2d to the 7th. All right, you can also think about this a different way. If we know that this is d to the 14th, you can say, okay, where do I have my extra variables? I have them on the bottom, and I have 7 extra ones down there, right? There's 14 on the bottom, 7 on the top, so you should be left with 7 on the bottom. All right, guys, thank you.